I'm back, and so are you. All right, please turn to part 7. The pages are a little bit wonky because I started rearranging the notes and the worksheets, so please be mindful of that. So I guess this is part 7. That's how you should find your notes, okay? I know on the bottom it does say page 8 of 14, so if you want to find that, okay? Identify the max and min values and zeros of the function in negative 2 pi to 2 pi. I know you also had homework problems like this. I really like these questions, and I think for a few of the classes, I've talked about it in class with you, but I thought I would go over this and just give you like a brief overview of part 7 and part 8. And the part 9 is applications, and I will go over those explicitly, okay, on the next video. So we have y equals negative 2x, y equals negative cosine 2x. Now, in your mind, as soon as I say that now that you're such pros at graphing, you should be able to sketch that in your head, okay? If you want to, you can show it too. So I'm going to just graph that. So I know it's negative cosine, so I know it's going to go from minimum, but I'm going to show twice because my frequency is 2, and I know that it started from the minimum because it's that's one cycle because it's a negative cosine graph, and also ended at the minimum. That's 2 cycles, and I know for sure that this is 2 pi. Oh, sorry, 2 pi, because I know that there's frequency of 2. That means it happened twice. The full cycle happened twice in 2 pi. So just having that idea is kind of nice. But let's just do the same thing. I forgot a peanut butter. Peanut butter. Okay, a peanut butter. Dang, of course. But think about what we're looking for here, max and min, and the zeros, okay? Now, I think zeros you deal with a lot, actually, throughout your algebraic years, right? Okay, so amplitude's pretty easy, right? You know it's going to be 1, okay? And you know what? Let's do the dang, okay? I think we're going to need that. Peanut butter, so B, right? B is 2. So peanut butter P, period, is 2 pi over 2, which is pi, okay? And D, so that means this guy is pi, right? 0, pi, and this is 2 pi here. Okay, that's good to know. We don't need to sketch exactly. And D, there's no vertical shift, so it's 0. Okay, so we should know that. Okay, well, let's start answering the first part of the question, right? It asks us for the max. How high does it go? How low does it go? Well, it starts at 0, right? Y equals 0. So the highest it goes is the amplitude amount, and the lowest it goes is the amplitude amount. Okay, that's the easy part. That's the easy part. Easy part, okay? All right, zeros. Well, you can kind of see the zeros, can't you? When you have that sketch. Of course, if you don't have a sketch, you should still be able to see the zero, and that's what we're going to talk about. But remember, in a normal cosine graph, well, if you go around the circle, right? If you go around the unit circle or just a circle, where is cosine 0? Cosine is 0 here and here. Pi over 2 and 3 pi over 2, right? Okay, so just have that idea. Okay, you know that for sure. Cosine of theta equals 0. Sorry, I'm going to write that better. Okay, cosine of theta is equal to 0 when theta is equal to pi over 2 and 3 pi over 2. We know that already. We have that in our mind. But the frequency doubled. So what do you think happens to the zeros? It should also double. We'll see. Okay, but if you can't think that way, it's okay. So let me do it again. The frequency is 2. That means from 0 to 2 pi, the cycle happens twice, the complete cycle. Well, we know that cosine of theta is equal to 0 at pi over 2 and 3 pi over 2 twice. But if the frequency doubles, that means it happens twice the number of times. So how do we find all that? So here's what you have to do. Okay, I'm going to do this in a couple of ways, okay? I'm going to go like this. I'm going to go this way first. Okay, I know that if you want to put x or theta, it's okay. But you see how this part here is 2x? I'm looking for when 2x is equal to, when 2x is equal to pi over 2, because that's when it's first 0. But also when 2x is equal to 3 pi over 2. Because I want to know when is it 0, right? But it's not when x is pi over 2. It's when 2x equals pi over 2. Do you understand that? It's when this angle becomes pi over 2. But there's an x, right? So the x would be pi over 4. And the x would be 3 pi over 4. Does that make sense? Huh. Okay. So it happens here and here, but there's other times that it happens. But because we need to find from 0 to 2 pi, it only found zeros here and here. So how do we find the ones that are here and here? Okay, that's the trick. So what I'm going to do is that, oh, but actually they gave us an interval, negative 2 pi to 2 pi, right? So we found only the ones right now where it's just from here and here. So how would I show that? Let's go like this. This and this is this and this. But we still need to find the ones behind us and also 2 pi. But you know, this could get a little bit long. So how about if we think of it this way? X, whatever your angle is going to be, is going to equal at 4 pi over 4, sorry, pi over 4. It's going to start here. But how often does this guy happen? And again, we know that it also has it here, right? This guy here. Here is the pi over 4. Here's the 3 pi over 4. But it happens to the left and to the right of it every how often. So I'm looking for this guy. How does it get to here? How much did it travel from here to here, right? That's what I'm thinking about. And I'm thinking about the period. How often does this happen? It happens every pi. So I'm going to go plus or negative pi, plus or negative pi. It happens every pi. Okay? It happens every pi. So what does that mean? So I'm going to do this. I'm going to go x equals pi over 4 plus or negative 4 pi over 4, just to make it easy. 3 pi over 4 plus or negative 4 pi over 4. And here's what happens. I get, so I start with pi over 4, right? That's the first time it happens. But what's the next one? It's 5 pi over 4. What's the next one? 9 pi over 4. You just keep adding 4 pi over 4. 13 pi over 4, etc. But also the other way around, right? The other way around. Same thing here. X equals 7 pi over 4. Sorry, I forgot to add 3 pi over 4, right? It happens at 3 pi over 4. It happens at 7 pi over 4. Next one, 11 pi over 4, etc. But we got to go to the left because it asks for negative 2 pi to 2 pi. So we're going to go to the left as well. So it's going to be negative 3 pi over 4. Negative 7 pi over 4. Negative 11 pi over 4, etc. Okay, this one too, negative pi over 4, negative 5 pi over 4, negative 9 pi over 4, etc. But only the ones in this, in negative 2 pi and 2 pi are the ones that you care about. So which ones are those? So we should have how many solutions? Well, from 0 to 2 pi, we should have 4, so we should have 8 total because we're going from negative 2 pi to 2 pi. Okay, so we're going to go everything that's under 2 pi, this guy, and then that's it for that one. And then this guy and that guy, because it's under 2 pi. And then for the negative, it's going to be this one and this one only, because negative 11 pi over 4 exceeds 2 pi. And negative 5 pi over 4 and negative 5 pi over 4, they exceed negative 2 pi. Okay, see, so if you understand that. So again, we talked about this. We said, we know for sure this graph, from 0 to 2 pi, it happens twice the full cycle of cosine. So we should have 4 zeros, which we did. We had this guy and this guy, this guy, this guy, and this guy, and this guy. But this guy asked for negative 2 pi to 2 pi, not 0 to 2 pi. So we had to go reverse negative 2 pi, and that's why there's 2 more. Okay, that's how you do these. So this is a really tricky part right here. Setting this guy up is very important. This setup here. Okay, and this right here is called the general case, but I forgot something here. It's pi times k. Pi times k. Why is it pi times k? Because it's every pi that this happens, times k, which k is just an integer value. Okay, k is just an integer, so like pi times 1, pi times 2, pi times 3, and we continue that. All right, this is a little tricky, so let me know if you have any more questions about it.